In this video, we'll begin our discussion of section 4.6. This is called variation of parameters. It's going to be exactly that. We're going to take parameters and we're going to make them variables. All right, so starting with a linear second order diffie-q, and then we're going to put it in standard form by dividing. So we're there, nothing new here. And then we have solutions to the complementary homogeneous equation. There is that solution. So the whole idea is, can the parameter C1 and C2 be replaced with actual variables, U1 and U2, some function to this? So this is a little different than what we've done in the past. In the past, you were given a Y1, and then you used Y1 to find Y2. What we're doing now is we're going to use the Y1 and Y2 to find a particular solution. Right, so it's not the other solution to the homogeneous equation. We are now dealing with a non-homogeneous equation. All right, so we are going to run through some theory here. It's going to be pretty long, so I think in my notes it takes me 2 pages to write out. So if you need to have scratch paper or write very small, please do. So we'll start off with the solution they gave us, but let's write it in more of a workable form. All right, so that's U1, Y1 plus U2, Y2. Now, for this, this is where it gets tough in the algebra. Once we start finding these derivatives, things get alphabet soupish. So be very careful, go very slow. All right, so the first derivative, I'm trying to remember to write small. I got U1 prime times Y1 plus U1 times Y1 prime. That's just the first set, and then U2 prime times Y2 plus U2 times Y2 prime. All right, and then we have to work all the way to our second derivative. So unfortunately, this next part is going to have 4 product rules. All right, so U prime prime, U1 prime double prime times Y1 plus U1 prime times 1 prime. I'm going to start underlining this to help with you, and then also to make sure I stay on track. Okay, that was that first one. I'm going to do the next one, U1 prime, Y1 prime plus U1 times Y1 double prime. All right, that was this one. All right, and then we keep going. Oops, wrong color. All right, plus U2 double prime times Y2 plus U2 prime times Y2 prime. All right, that was this one. Oh, not the whole thing, just this. And then the last one, okay, is going to be U2 prime times Y2 prime plus U2 times Y2. All right, so there's our second derivative. I forgot to mark it there. Okay, so we need to plug that into our equation. I think we can simplify my second derivative, which, if I remember correctly, I think I split later. So yeah, let's not combine any like terms at all. All right, so let's go ahead and plug all 3 of these into the standard form diffie-q. Okay, I'm going to keep that x there because I need to remember that it is a function of x. All right, and that's also times y. All right, so plugging all this in, I am going to just write straight from my notes. When I put this together, I'm going to keep the p's together and I'm going to keep the q's together for a moment. Okay, so we get u1 double prime y1 plus u1 prime y1 prime plus u1 prime y1 prime. We get 2 of those plus u1 y1 double prime plus u2 double prime times y2 plus u2 prime y2 prime plus u2 prime y2 prime. We get 2 of those plus u2 y2 double prime. And then I'm going to put the p's and q's down here. Okay, so p, I think we can handle, yeah, I don't think we could just put p. I think there's in previous video where we needed p to be a function of x. I think in class I put a p and I assumed it was a constant. We got to remember it is a variable or an expression of a function of x. All right, so I have everything that was multiplied by p. All right, u2 prime, y2 plus u2, y2 prime. All right, and then we need the q terms. So q times u1, y1 plus u2, y2. All right, so that's all of that. Now I'm going to reorganize. What I'm going to look for is we're going to put our U1s together. So if you notice, we have a, let's highlight in blue here. I have a U1 there. I also have a U1 here and a U1 there. That's the only U1 that's not a prime. And then I also want you to take a look. We're going to look at U2. So U2, we have one right here, and one right there. All right, so we're going to put all the U's together and all the U2s, and then we'll leave everything else after that. Okay, so what we're going to get is we're going to get U1 times Y1 double prime plus PY1 prime plus QY1 plus U2 times Y2 double prime plus P times Y2 prime plus QY2. And then the rest of this is going to be plus U1 double prime Y1 plus U prime U1 prime, Y1 prime, plus U1 prime, Y1 prime. We still have those two, plus U double prime 2 plus Y2. And then two terms U2 prime, Y2 prime, plus U2 prime, Y2 prime. And that's still not it. We still have those P terms. We don't have any more Q. We used all of those. So here's the times P that were left. U1 prime, Y1, plus U2 prime, Y2. Okay, and then we're gonna add a page here. Sorry, I know. Hopefully, I can remember to put the notes to put a spare page here. If not, I hope I gave you a fair warning. All right, so a couple things here. Remember that we have our initial, like this is our formula up here that we're working with, our diffie q, and I can see it that I have that form right here and right here. But both of those forms are with Y1 plugged in for the first one and Y2 plugged in for the second one. But remember, up here, the Y1 and Y2s were the solutions to the homogeneous case. So what that means is that when I plug those into the diffie Q, these go to 0, right? They're solutions to the homogeneous case, which means they produce zeros. All right, so that leaves me with the rest of this. I'm gonna go ahead and copy and paste. Did I get it all? Yeah, I believe so. All right, I'll put this P over here, and I can erase that initial plus sign. All right, so that's what we have now. Right, I'm going to put a few things together here. Okay, we're going to do U2, Y1. I'm going to put these together, and U1, Y1 prime. So we'll put right next to it together. All right, and then I'm going to put what we're going to do with those two. Notice that if I take the derivative of U1 prime times Y1, I get that. Here, let me put that in pink, actually, because I think that would make sense. This U1 prime times Y1, if I take that derivative, I get what I have underlined in buff by the product rule. I'm going to do the same thing for, okay, what else do we have? U2 prime, there should be, oops, some of you guys were probably screaming at me there. Those are gone. There's no plus there. I think I did that in class too. All right, so for this one, I'm going to underline now with a different color. We'll do orange. Okay, so U double prime, and then we're looking for U2 prime, Y2 prime right there. So those two can also be written as d dx of U2 prime times Y2, right? And then we write the rest here. Okay, I'm going to get a plus P, I'll put the P's first, U prime, U1 prime times Y1 plus u2 prime times y2. And then at the very end, I'm going to have u1 prime, y1 prime plus u2 prime, y2 prime. Okay, so we can go one more step. I can take this line here, and I know that derivatives, when they're added, two terms are added, I take the derivatives separately. So this would mean the exact same thing as what's right above. Right, and then that's still sitting there. Okay. Want you to, this is equal 1 starting off. This is equal to f of x. That's going to be the right side of our equation. So if that's equal, now we want to make some assumptions here. Remember, we are creating this u1 and u2, and we're wanting them to be variables. I want this to be true, what I have right here. I want those two equations, the last two lines to be equal. So we're going to make some assumptions to make our life easier. Now, if I were looking at this equation and I was wanting to create some kind of diffie from it, one assumption that we could make, and it's not totally obvious, but kind of here, but look here and here. Those two things are the exact same thing. We did that on purpose. Somebody worked with this, manipulated it. I knew our end goal, and I just headed towards there. All right, so what we're going to assume is that we're going to assume y1 prime times y1 plus u2 prime times y2. We're going to say, hey, that would be really nice if that was a 0. Because if that were a 0, then I know that u1 prime times y1 prime plus u2 prime plus y2 prime. I said plus times. Did that now twice. That needs to be equal to f of x. If the blue ones are 0, then this thing here must be equal to that. That's the last thing we wrote. So what we have created is a system, right? We just need to solve. Now, if you look here, I have a u1 prime and a u1 prime. That's the first variable. And then u2 prime is our second variable. So our coefficients for this system are the y's. All right, so I'm going to teach you a rule. It's called Kramer's rule to solve a system. So Kramer's rule, it's using the Wronskian. So if you'd like to look this up, maybe get some more information on it, please do. How the system looks is we throw this in a matrix, y1, y1 prime, y2, y2 prime, and then times 0, f of x. So it's your normal Wronskian, except for I will have that 0 f of x thing at the end. So how I treat this, we're going to do Wronskians, but it's not going to be all three of those at the same time. We're going to take the Wronskian itself with our y1 and our y2. All right, what that looks like with the Wronskian, remember, is y1, y1 prime, y2, y2 prime. All right, and then we're going to come up, we're going to have three matrices here. Then I'm going to have something called y1. What y1 looks like is you replace the first column, the y1, or I said y1, w1. I replace y1 column with 0 f of x, and I leave f2, y2. One day I'll get the letter straight. Sorry, guys. All right, I have that. And then w2. I keep the y1 now, y1 prime, and now I replace that column with f of x. These are all determinants, so you'll treat them the same as we've done in the past with the Wronskian. Luckily, these are 2x2s that we'll change here in a bit. What we get from this is Kramer's rule, that I get the variable u1 prime. Remember, that was what was in question at the top. That's what we're trying to find. This is going to be equal to w1 divided by w, which means that I can find u1 by taking the integral of w1 over w dx. Same thing for u2. So u2 prime is equal to w2 over w, which means w2 is equal to the integral of w2 over w dx. And that's how we'd find w. We'd multiply them by our original functions, our y's, to get our new solution. So, okay, I'm going to work an example from this because I know going through this feels like I said, alphabet soup. There's a lot going on. Also, I knew exactly where we were trying to go. So you might be feeling like, I don't know how you would have ever thought to get there. Well, somebody did it before me, and I saw how they did it. And then it's just standing on the shoulders of giants, right? You're not going to come up with, you might have came up with this. That would be great. Um, but yeah, let's move forward. All right, let's do an example. So here's our first one. Notice that this is a non-homogeneous um, diffie because I have that function that's over there on the right. Um, and so to solve for a particular solution, I'm going to need a homogeneous solution set. So first things first, we'll do that. Y sub c, our complementary um, homogeneous solution. So that diffie will be y double prime times 2y prime plus y equals 0. All right. Then we're going to use our method here. We're going to use the e to the mx method here. So I get m squared times 2m plus 1 equals 0. If I factor that, I get m plus 1 squared. So that means m equals -1, but it's repeated. Or you could even say multiplicity 2. What that means is that I get my first solution by C1 e to the negative x plus C2 x e to the negative x. All right, so we're gonna throw these in matrices. That x to the e to the x is gonna make it not so fun. All right, so there was that solution. That's to the homogeneous case. Now I pick up my y1 in this method, which was e to the negative x. And I'm going to pick up my y2. I'm going to go ahead and just put them in the form that I'm going to need it to look like. Y2 is going to be x times e to the negative x. All right. I know that I'm going to use the Wronskian, so that means I need derivatives of these. So y prime of x is going to be negative e to the negative x. Y2 prime of x it's a product rule. So I take the derivative of x, then I'm going to take the derivative of e to the negative x. Okay, let's go ahead and put that in a factored form. Maybe it'll help us out later. All right, and then I'm going to go ahead and name f of x, which was the e to the negative t. Oh, we've been using x's this whole time while those were t's. I'm going to go ahead and just change it for my video. All right, we're going to leave them in x's. We can change them at the end if it bothers you that much. E to the negative x times ln of x. All right, we don't need a derivative of that. All right, so we're going to run the Wronskians. I like to put these three across, so write pretty small. So the Wronskian for these functions is going to be e to the negative x, negative e to the negative x, and then I'm going to write the bottom one first since it's longer, negative ex1 minus x, and then that's above x times e to the negative x. All right, so I got to multiply here. I'm going to get e to the negative 2x times 1 minus x. All right, and then minus, but it's going to turn into a plus. And then I get x times e to the negative 2x. Charger that right here. Okay. Oh, I said I was going to work down, so down here. All right, and then notice that if I do that, I'm going to have two terms that cancel, leaving me with just an e to the negative 2x. That's nice. All right, I'm going to do a W1 now. All right, W1 is going to be equal to, okay, I do a 0, and then I do e to the negative x times ln of x, and then I keep the second row the same. So e to the negative x times 1 minus x, and then above that's going to be x e to the negative x. This multiplication is going to be a little simpler because I get a 0, but then I get a minus x e to the negative 2x ln of x. Right, I'm going to shrink these up just a bit. Right, W2. I keep the first column now. And then I changed the second column to 0. And then what did we have? E to the negative x, ln of x, f of x. All right, and then working that out, I can see that I'm going to get e to the negative 2x times ln of x. Okay, so there gives me, I have w, w1, w2. It's not pretty, and that's okay. So u1 prime, right, is going to be w1 over w. So w1 is negative x, e to the negative 2x, ln of x, divided by e to the negative 2x, which is going to leave me with a negative x times ln of x. All right, so we need to integrate from there. So to get u1, I'm going to integrate negative x times ln of x dx. Now this is going to take us a bit. It's going to take a u sub and then tabular. It's going to take two different things. So let's work through that. The u sub here that we're going to use, we'll do u equals ln of x, which means du is 1 over x dx. I'm going to move that over the x to get here. Now I need to find a way to deal with this x here, and then we're going to have this x to deal with there. If I take this, I know that I can flip that around, and I know x is e to the u. So if I change this equation, okay, I get the negative out front, and then I'm going to have x times u du. And then that's not going to be doable with the x's. We'll replace with the e to the u's, giving me e to the 2u times u du. All right. And then this is just tabular. So we'll do the tabular right here. I can see it's tabular because I know u's going away, and then e just keeps coming. All right. So plus or minus d dx. And the derivative of dx, I got plus, minus. I know I'm going to have a u, 1, 0. And then e to the 2u. 1/2 e to the 2u, and then I'm gonna put this right here, 1/4 e to the 2u. I guess I could put that down below. And then that's all I gotta go because that's 0. We just gotta be careful here. This 0 is right there in that row. Okay, so my solution then for that integral would be negative, and then it's gonna be 1/2 times u, let's go all the way back, ln of x, times e to the 2 ln of x. Okay, and then it's going to be a minus 1/4, and then e to the 2 times ln of x. We can definitely clean this up. All right, I'm going to get negative 1/2. The e to the 2 ln of x, that 2 is going to go up to the power, provide it'll be e to the ln of x squared, which is going to just get me an x squared times ln of x. And then minus 1/4, and this is that same thing. All right, so there's u1. We got to do u2 now, which I believe it's going to be a little simpler if I remember. W2 over W. All right, so W2 then was I think it's right here. Oh, we don't have the X this time, so that's nice. E to the negative X times ln of X divided by W, which was e to the negative X. That means that W2 is ln of X. All right. This is interesting how to do this integral. So to get u2, we're going to do the integral of that, ln of x dx. How we do this integral, we can actually use a u sub again, almost in the same fashion. So u will be ln of x, du then is 1 over x dx, which means x times du is dx, and then I can change this original again, e to the u is x. So if I'm u subbing this, I have to introduce the x, so I'm going to get integral of e to the u times u du. ln of x was u, the x that I introduced with my dx gets replaced with e to the u. This is very similar. Oh, these should be two x's, I think, on those. Yeah, these should be two x's, but that's okay. It doesn't affect our problem. They still went away. I'm just trying to check to see if anything else, make sure we're right before I take down this path. Okay, cool. So we have that. This is just a another tabular. It's very similar to the one we just did. Just easier, I think. We got plus, minus, plus, and then we're going to put the u here, 1, 0, and then e to the u, e to the u, e to the u. So the solution to this is going to be ln of x times e to the ln of x minus e to the ln of x. Okay, so if I work that out, I got x times ln of x minus x. Okay, so we have that. So our final solution will be the all of it there. So I'm at y equals, and we're going to get c1 e to the negative x plus c2 x times e to the negative x. And then I get this particular solution. So I'm going to get, maybe we should write out p first, actually. Forgive me. Let's write out p first. I was trying to jump too many steps. So y sub p is going to be u1 times y1. So u1 was, where did we get our solution? That was right here. So we're going to get that whole thing, negative 1/2 x squared times ln of x minus 1/4 x squared times e to the negative x. And then the second equation, I'm going to have x times ln of x minus x times e to the negative x. So that's y sub p. I'm actually kind of out of room here. Y sub y, or so y sub y. Our general solution y will be y sub c plus y sub p. All right, I'm going to leave it there. We have our solution there in a way. It really is the end solution, but I have a y sub p. I have that there. And then I also described the y sub c. We should probably put a c on those. All right. So that's how we do these. It's the integration is probably the worst part. Like I think most of this is you just got to figure out how do I go about these weird integrals without having to memorize. All right, we'll do. I think there's another problem that's pretty couple of problems that are simpler, and then we'll do one higher order one, which takes a little bit of time.